Hi and welcome everyone. Today we are starting with our new topic probability and statistics, which is a whole course in our engineering programs. Today is our introduction lecture, so we will start with the topic basics of probability, in which we will learn about some basic terms and solve some examples so we can get familiar with the concepts. Our first term is sample space. Sample space is a set of all possible outcomes. For example, we roll a die. So what are the possible outcomes? 1, 2, 3, 4, 5 and 6. So this is our sample space which contains all of our possible outcomes. Our next term is an outcome. Outcome is a result of random experiment. For example, we toss a coin. So what are the result of that? Either it is a tail or a head. So getting a tail or a head as a result is the outcome of our trial. Our next term is random experiment. Random experiment is an experiment in which if we conduct n number of trials, then every time the outcome is not unique. It can be from any possible outcomes. That means if we roll a die, we want to be getting every time 1 or 6. The outcome will be from any of these possible outcomes, but not a single outcome every time. Example of a random experiment is, for example, selecting a student from a class of 40 students. Every time teacher will not select a single student. It is from any students of that 40 students. Our next term is a trial. Trial is an instance of random experiment. For example, in a random experiment, we roll a die for n number of times. So rolling a die for each time is an individual trial that will result into an outcome. Our next term is an event. Event is a set of our favorable outcomes which is a subset of our sample space. For example, I want to get an odd number when I roll a die. So what will be my event? Event E equals to 1, 3 or 5. Now 1, 3, 5. This set is a subset of this sample space in which we have all of our possible outcomes. So an event contains every favorable outcomes for a trial from its sample. Our next term is mutually exclusive events. For example, I have an event B and other event A. Then if A's favorable outcomes are totally different from B's favorable outcomes, when they are selected from a sample space S, then they are mutually exclusive events. For example, my A is getting a odd number, so it will contain 1, 3, 5, and B is getting a even number. When I roll a die, then its outcome will be 2, 4, 6. And let's take one more event C, which is getting a number from 1, 2 and 3. Now if you will see, we don't have any single outcome which is common in A and B. So A and B are mutually exclusive events which are taken from sample space 1, 2, 3, 4, 5, 6, which is for rolling a die. But if we see in A and C, we have some common outcomes, so they are not mutually exclusive events. A mutually exclusive events in which a pair doesn't contain any single common favorable outcome. Our next term is independent events. Independent events are the events in which occurring or non-occurring of an event is not affected by supplementary knowledge about occurring of the other event. For example, A is a student which stores a coin, and A is the event getting head on coin, and B is also getting head on coin by A and by B. So is output of A tossing a coin is getting affected by the outcome which B get on tossing a coin? No. So they are independent events. Next term is equally likely events. Equally likely events are the events which have the same property. For example, if A is getting a number from 1, 4, 6 on rolling a die, and B is getting a number from 2, 4, 6 when rolling a die. So what is the probability of A? Probability of A is equal to number of favorable outcomes, which are 1, 2, 3, by total number of outcomes, which are the size of sample space, which is 6. So our probability is 1 by 2. Probability of B. Total number of favorable outcomes 1, 2, 3, by total number of outcomes 6. It is 1 by 2. As probability of A equals to probability of B, that's why A and B are equally likely events. Now we will solve some questions so we can get grip on our concepts. Our question is, when two unbalanced die are thrown, find the probability of getting total number on die greater than 8. So if we roll a die, what is our sample space? 1, 2, 3, 4, 5, 6. So now we will extract the pairs which get the total number of dice greater than 8. So our first pair is 3, 6, because their sum is 9. Our next is 6, 3. Getting 3, 6 and 6, 3 are not identical. They are not the same. Getting 3 on first die, getting 6 on second die, getting 6 on first die, getting 3 on second die. So we have to count the both. Now our next is 4, 5, 5, 4, 5, 5, 4, 6, 6, 4, 5, 6, 6, 5 and 6, 6. These are the pairs which we will get the sum of the both number greater than 8. So what are the total number? We will count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 favorable outcomes and total number of outcomes is 36. So our probability will be 5 by 18. Our next question is, when we shuffle a pack of cards, we accidentally lost 4 cards. We have to find the probability that missing cards are one from each suit. So we have to choose one card from each suit. So 13, 7 into 13, 7 into 13, 7 into 13, 7 and selecting 4 cards from the suit, that is 52, C4. So you can lift it up to here or you can again solve it, but this next question is, in a random arrangement of letters of word mathematics, probability of getting all vowels together. Our word is mathematics. We have vowels A, E, A, I. So we have to put these four vowels together. For example, we make a box in which we put A, E, I together and consider it as an element. And now we are left with 1, 2, 3, 4, 5, 6 and 7. We have one element as this box and 7 consonants. Now what is the probability, what is the number of arrangements we can get by this? Our number of arrangements will be 8C1 into 7 factorial into 4 factorial by 2 factorial. I will tell you why I am doing this. We will select from the 8 places one place for our this box or pack of vowels. Then we will arrange the consonants. So it will be 7 factorial, and arranging the vowels in this box, it will be 4 factorial by 2 factorial. By 2 factorial because we have 2A. This is the number of arrangements by our total number of arrangements. Our total number of arrangements will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 factorial by 2 factorial. Because 11 factorial, we have 11 letters in this one and we have 2 A's. So it is repeated, that's why we will divide it by 2 factorial. So our answer will be 8 factorial upon 4 factorial by 11 factorial. If we will expand this, so we will get 4 factorial by 11 4 into 3 into 2 by 11 into 10 into 9. 5, 3.